Hey there, it's Kaylee. Before we jump into this lesson, make sure you already know how to evaluate expressions with one variable. There's a whole lesson on it. If you already know how to do that, then make sure you know all about exponents. There's also lessons on those. If you know how to calculate exponents, then let's get started. This problem says evaluate the expression 2 to the power of x plus 3 when x is equal to 4. So what do? Well, let's recall our 3 simple steps to evaluate expressions. Step 1, write the expression in our own handwriting. Step 2, wherever we see the variable, we use substitution to plug in our given value. And step 3, evaluate using order of operations. So let's do it. Starting with step 1, let's write out the expression. It's 2 to the power of x plus 3. And now let's go to step 2. Wherever we see the variable, we use substitution. So where's the variable? Yeah, x is up here. It's the exponent here. And my given value is x is equal to 4. So I'm going to plug in my given value wherever I see my variable, which is up here in my exponent. So I have 2 to the 4th power plus 3. And now I can go to step 3. I can evaluate my expression using order of operations. So I do my exponent first. 2 to the power of 4. That's the same as 2 times 2 times 2 times 2. So if I do that, 2 times 2 gives me 4, times 2 is 8, times 2 is 16. So this is 16 plus 3. And doing my addition, I get 19. So this is the answer when I evaluate this expression with the given value, x equals 4. Awesome job. Okay, so this one says evaluate x squared. Remember, that is a way of saying x to the 2nd power plus 3x when x is equal to 5. So what do we have in our first term? Yeah, we have an exponent, but this time our variable is the base, not the exponent. Nice. And how about our second term? Yeah, we have a product. We have 3 times x. What's that fancy name for 3 again? Yep, the coefficient. Good memory. So let's rewrite our expression in our own writing. It's x squared plus 3x. And remember what step 2 is. We're going to substitute our given value. So in this case, x is equal to 5. And I have variables in my first and my second term. So let's substitute those out. I'll have 5 squared plus 3. Remember, I use my parentheses because it's multiplication, not 35. Perfect. Now I can go ahead and I can evaluate using order of operations. So first thing, I'm going to do my exponent. 5 squared, remember that, is 5 times 5. So I have 25 plus 3 times 5. Now I'm going to do my multiplication. So I'll have 25 plus 3 times 5 is 15. And now if I do my addition, 25 plus 15, remember I can think 25 plus 10, that'd give me 35, plus my other 5 is 40. And there we go. So 40 is the answer to this expression up here when we evaluate for the given value, x is equal to 5. Good job. I know evaluating these exponential expressions is pretty fun, but they do have a use in the real world. Many scientists use exponential expressions to do their research. Let me show you an example. Did you know that most contagious viruses, like the flu, spread exponentially? Under certain conditions, the equation for the spread of a virus can be written like P equals 2 to the power D minus 1. In this equation, P is the number of people who get sick, and D is the number of days that have passed since the very first person got sick, which we call the outbreak. So let's use this equation to find out how many people have gotten sick. The variable P, if it has been 3 days since the first person got sick. That would mean when D is equal to 3. We can compare that number to a week after the outbreak, when D is equal to 7. So let's evaluate when D is equal to 3. We'll start with this first one here. So I'm going to rewrite my equation. I have P is equal to 2 to the power D minus 1. Now I'm going to substitute in when D is equal to 3 in for my variable D. So I'll have P is equal to 2 times the power 3 minus 1. So now I can start to evaluate, right? P is going to be equal to 2. I'm going to put this in parentheses just to be clear. I need to do this little subtraction first. 3 minus 1, that's 2. So 2 squared to the second power, that means 2 times 2 is going to be 4. So this tells me P is equal to 4. The number of people that are sick is 4 after 3 days, or 3 days after the first person got sick. Okay, now let's compare it when D is equal to 7. So I'm going to rewrite my equation over here. I'll have P is equal to 2D minus 1. Now I'm going to substitute this 7 in for my variable D. So I'll have P is equal to 2. I'm going to use my parentheses to make it clear. 7 minus 1. So now I'm going to do order of operations. I'm actually going to do this little parentheses up here first. 7 minus 1, that would give me 6. So this is 2 to the 6th power. So that's going to be 2 times 2 times 2 times 2 times 2. One more, times 2. So what does this give me? 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. 32 times 2, that's 64. So this is equal to 64. And that means P is equal to 64. So that means 7 days after the outbreak, there's 64 people that are sick. That's just 4 more days than when D is equal to 3, and only 4 people were sick. So in the span of 4 days, we went from 4 to 64. That's a lot of people. This is pretty interesting stuff, right? We're doing hard science right now. And this type of science is called virology. You are an amazing mathematician and scientist. Great job learning about exponential expressions with one variable. You're ready to practice on your own. You can always come back to these 3 simple steps to help you. Have fun and remember to always be clever.
Hey.